This is Mars, otherwise known as the Red Planet. On February 18, 2021, Perseverance, NASA's
$2.7 billion rover, ascended onto Mars.
Why is this even important, you're thinking? But you should already know that Mars is the most habitable planet after Earth.
Meaning if something goes bad here on Earth, I'm not saying it will, but we might have to jump on a rocket and fly ourselves to Mars. That's why Perseverance is up there, studying all about the geology of Mars. But how does it do it? Have you wondered how the Perseverance rover and so many other rovers stay alive on Mars? If you get solar panels, batteries, chipmunks, monkeys, magics, and hamsters just running around their wheel, that's not quite it. With varying weather conditions, scientists can even consider solar as a viable source of power. We need something that's reliable, but most importantly, lasts for a very, very long time. That's why scientists have turned to radioactive material like plutonium-238. Plutonium-238 is the main element inside the radioisotope power system. More specifically, the multi-mission radioisotope thermoelectric generator. Its job is simple: convert heat to electricity. But how does it do that, you may be thinking? To get a better understanding of how this works, we need to take a step back and understand how traditional energy is made. Fossils like coal and uranium are used to heat water until it produces steam or heat energy. Then that heat energy is used to power a turbine, which produces mechanical energy. That mechanical energy is utilized by the generator to create electrical energy. But the main barrier in producing electricity this way is the fact that 2/3 of the initial energy generated is lost as waste heat. That's where MMRTG and plutonium-238 come in. Plutonium-238 is a radioactive isotope which has a half-life of 87 years. That's pretty big. You see, with the use of plutonium MMRTG, scientists are able to eliminate the mechanical component from the equation. The process now becomes simply from thermal to electrical. That's huge! Think of it like this. You take a piece of metal and heat one end and cool the other. The electrons on the hot end would have more energy, in turn making the electrons on the hot end move towards the cold faster than the cold move towards the opposite, therefore causing the hot end to be positively charged and then cold to be negatively. But in our case, the cold end is replaced by the vigorous atmosphere and the plutonium-238 replaces the hot end. If you still don't get the thermoelectric effect, go check out my website, shibu.com. You'll have an interactive diagram which you could play with. I worked very hard on that. Imagine if we could use this technology in our cars, meaning instead of letting all the heat we burn in our cars out into the air, we use that heat, transform it to electrical energy, and which powers other parts of our car. Our universe is inconceivably large, and with this fractal stepping stone of innovation, there's no limit to where it can take us. Thanks for watching.